Hello, Glendale Community College. We are here for our last video on our solutions chapter, our liquid and solutions chapter. This is going to be a fairly long video, so get ready. We're going to talk about solution stoichiometry. Oh boy, remember when we talked about stoichiometry? We went from grams to moles to moles to grams. We used that mole ratio. We had two chemicals in the problem in a balanced reaction, and we went from grams to moles to moles to grams. Well, now we're going to add molarity into that. So molarity can be used to convert between moles of the solute and the volume of a solution. So it can be a conversion factor to get to moles. And remember, stoichiometry is all about a mole ratio. So you have to have moles. So molarity is moles of solute over liters of solution. It's a conversion factor because it's a fraction, right? So we can convert between moles and liters. So we can use this with chemical reactions. So using the molarity and volume of reactants and products, we can do solution stoichiometry calculations. Here we go. So here's our new chart for stoichiometry. Let me downsize myself. We have liters of A, and we use the conversion factor of molarity of A to get to moles of A. Then we would use the mole ratio to get to moles of B. We can use the molarity of B, which is a conversion factor, to get to liters of B. Now down here at the bottom is what we already know. Grams of A, use the molar mass to get to moles of A. Use the mole ratio to get to moles of B. Mole ratio comes from the balanced equation. Then we can use the molar mass of B to get to grams of B. So again, we can do grams to moles to moles to grams, but what we're learning now is this additional piece where we can do liters to moles to moles to liters. For solutions. It has to be solutions. All right, let's look at an example. How many liters of a 1.23 molar calcium hydroxide solution is needed to react with 0.254 liters of a 0.756 molar HCl solution? I know. Wow. This is tough. This may be the toughest thing we're doing all semester. So we have calcium hydroxide and we have hydrochloric acid. We have two chemicals. We know the molarity of calcium hydroxide, but not the liters. We know the molarity and the liters of hydrochloric acid. So let's go back again and look at our path. Liters to moles to moles to liters. We need to know the liters and the molarity to get to moles. So our first chemical is going to be the one we know the most about. That's the hydrochloric acid. So we're going to start with the liters of hydrochloric acid. So let's remind ourselves, the molarities can be used as conversion factors. 1.23 M means 1.23 moles per liter. 0.756 M stands for molarity, means 0.756 moles per liter for those two chemicals. Now, we need the balanced chemical reaction. This is great practice. Why don't you hit pause and write the balanced reaction? It's an acid-base reaction, isn't it? We have H in front of HCl, so that's an acid, and we have OH in back of calcium hydroxide, so that's a base. So we have an acid-base reaction. I put the base first because it doesn't matter. So I have my base plus my acid makes my water plus my salt. Calcium chloride is my salt. Calcium is +2. We got to check the charges. Cl is -1. So it's a 2-1 combo. Calcium is +2, Cl is -1. So we need 2 Cls to go with the calcium. I left off the states just because I was running out of room. But when you write reactions, you need to write the states down. Yeah. Okay, so let's do this calculation. Again, we know the most about HCl. That's what we're going to start with, liters of HCl. So 0.254 liters of HCl. We're going to use the molarity of HCl as a conversion factor. There is 0.756 moles of HCl per 1 liter of solution for HCl. Liters of HCl cancel out. Now we have our moles. Once we have our moles, we can do our mole ratio. Moles of HCl has to be on the bottom to cancel out. There are 2 HCl's, so 2 moles of HCl's on the bottom. There is 1 calcium hydroxide in the reaction. So 1 mole of calcium hydroxide is on top. Moles of HCl cancel out. Then our last conversion factor, we're going to use the molarity of the calcium hydroxide, but we're going to put it upside down because we need moles to cancel out. So we need the 1.23 moles of calcium hydroxide on the bottom. 1 liter of calcium hydroxide is on top. Moles of calcium hydroxide cancel out. We're left with liters. The question was how many liters? Put it into our calculator. We get 0.0781 liters of calcium hydroxide. Woo, that was a tough one. Okay. I'm only doing this one example in the video, so I'm going to try to find some other examples for you to watch. You will need to work the example problems in the worksheet and at the end of chapter problems. Okay, solution stoichiometry is something you will see on your exam, possibly the final. So you need to know how to do this. It's a units game. Liters to moles to moles to liters. Follow your units. All right, good luck. Last thing in this chapter is something we're going to do in lab. It's a titration. Titrations can be used to find the molarity of an unknown solution by reacting it with a solution for which we do know the molarity. We do these with strong acid, strong base titrations. In a strong acid, strong base titration, we add one of these to the other slowly until the solution is neutralized, which indicates the reaction is complete. Because we know the volume of both the acid and the base that we used, we can calculate the molarity of the unknown solution. Here's an example. What is the concentration, i.e. molarity, of vinegar if it takes 15.42 milliliters of vinegar to neutralize 20.03 milliliters of 0.9972 molar strontium hydroxide? Again, wow, I know this is very complicated. So we know the volume of vinegar. We know the volume of strontium hydroxide, and we know the molarity of strontium hydroxide. So what we're missing is the molarity of the vinegar. HC2H3O2 is acetic acid. I call it vinegar. It's acetic acid. So this is not what we just did, because that we were finding liters, right? It was liters to moles to moles to liters. We were finding liters. This is asking for concentration. So this is different. Okay, this is asking for concentration. Again, we're going to do this in lab. Remind you that 0.9972 molar means 0.9972 moles per liter. That is a conversion factor. There's 1,000 milliliters in a liter, right? So we need to convert our milliliters to liters. There's 1,000 milliliters in a liter. So 15.42 milliliters is 0.01542 liters. 20.03 milliliters is 0.02003 liters. All I did is change milliliters to liters. We're going to need liters in our calculation. We need a balanced equation. So this is again an acid-base reaction. We have an H in front of the vinegar, acetic acid, and we have an OH in back of strontium hydroxide. So we have an acid-base reaction. There we go. It is balanced. Again, I left off the states just because it's getting busy. All right, let's do this calculation, similar to what we're going to be doing in lab. We're going to start with our liters of strontium hydroxide because that's what we know. The molarity is a conversion factor. So start with liters, 0.02003 liters of strontium hydroxide. Use the molarity as a conversion factor. 0.9972 moles over a liter. Liters cancel out. Now that we have moles, we can do our mole ratio. So this is similar to what we did last time, but slightly different at the end. There is 1 mole of strontium hydroxide in the reaction. That goes on bottom, so moles of strontium hydroxide will cancel out. We're finding out about the acetic acid or vinegar. There are 2 moles of vinegar in the reaction. So 2 moles of vinegar is on top. This will get us moles of vinegar, and it's 0.03995 moles of the vinegar. But we want concentration or molarity. What is molarity again? Remember, if you ever forget, it's on the back of your periodic table. Molarity. It's moles per liter. Well, we got the moles. We have the liters, so all we have to do is divide. We're going to take our 0.03995 moles of vinegar divided by the 0.01542 liters of vinegar to get our molarity of vinegar, which is 2.591. Again, we're going to be doing this in lab. Go over this one again if you need to. All right, that's the end of chapter 12. Okay, my biggest advice to you is there was a lot of math with solutions in this chapter. You need to go to the end of chapter problems and the worksheet and work those examples over and over again. Maybe rewind the video and watch those as well, because I only did one in the video. I will try to find additional videos that you can watch as well. All right, good luck. Long chapter. You got this. You can do this. Bye, GCC.